to the driven, from driver to the driven. Okay, so this shaft is can transmit the power as well as it also carries the load. It also carries the load. Normally, shaft is of circular cross section. Circular cross section. So now, based on the obtained dimension, so we can go for manufacturing or turning of the an ingot or a circular bar into required diameter. Okay. So for example, let us consider a electrical motor is here. Okay. So now it has a consist of a shaft. That means it is mounted in housing. So where it carries in rotor here. Okay. So the shaft is now connected to this water pump. Okay. This is what? Water pump. Okay. So now power from this electric motor is transmitted through this water pump with the help of shaft here. With the help of shaft. So as I said, shaft is circular cross section. Circular cross section. Okay. Suppose if it is a rotating member, okay, if it is a rotating, okay, so then you can say it is a shaft. You can say it is a shaft. If it is a non-rotating, if it is a non-rotating, okay, then you can say it is a axle. Okay, you can say it is a axle. So axle is a member which is going to support the loads. Okay, it is going to only support the loads and it does not carry any power. Does not carry or transmit any power. Okay. So one example I can say axle is a small circular member which is fixed in HSC of your motorcycle. So where it is going to support the wheels. Okay, where it is going to support the wheels. Now, so the different type of shafts which are going to come in the mechanical field or in mechanical design. First one is a simple shaft head which is used to transmit the power from one position to another position. Okay? So that type of shafts are called as a line shafts. That type of shafts are called as a line shafts. And some shafts are used to transmit the power for a very short distance. For very short distance. So that type of shafts are called as a spindles. That type of shafts are called as a spindles. Okay. Suppose if it's going to use for longer distance, okay, if a shaft is used for large distance, if the distance between the sources, that is what driver and driven, okay, in between if we have any other drivens here, then this type of shaft is called as a long shaft. This type of shaft called as a line shaft, not a long shaft. Line shaft, right? So basically, we're going to get three type of shafts. One is it's what a cylindrical shaft. You can call that one as to line shaft. Another one is axle. That is what non-rotating member. And a third one is third one is a spindle here. It is what a Spindle. So spindle is a shaft which is of a heavy having a very short distance here, having short distance. Okay, so that means around about nearly 1 meter, nearly 1 meter or less than 1 meter, less than 1 meter. Okay, so that's going to impart the motion. So either to a cutting tool or to a workpiece. Okay, either to a cutting tool or to a workpiece. So now spindle is now I think you have seen spindle in lathe machine. In lathe machine. Okay. Next. So what are the properties of a material it should have? What the requirement of materials? Requirements of shaft material. Okay. So as you're using this shaft in a different environments, okay, or different places, so it should have some properties. It should have some properties where it can sustain. So all the what you can say the environments, all the environments. So where it can work easily. So without making any failures, without making any failures. Okay. So the shaft materials used for that means the material used for shaft should have the following properties. Okay. The material, okay, the material used for shafts should have following properties. Okay. So first one, you should have a high strength. Second, so it should have good machinability. Good machinability. So third one, so it should have a low notch sensitivity factor. It should have low notch sensitivity factor. So it should have a good heat treatment properties. And also last one, it should have high wear resistance properties. It should have high wear resistance properties. So first thing is it should have a high strength. Okay, so because if the material is of a very high strength, so you can go for smaller dimension shaft to carry the large power. Okay. Second one, it should have a good machinability because so based on the dimensions uh, to increase to decrease the size of the material to the required diameter, it should give a good machinability. Along with that one, so as you need to place some pulleys, gears, and some components over the shaft, so it should have a good machinability. That means you can easily cut the keyways or you can easily drill the holes, okay, as to mount the gears, pulleys. Okay. Next, low notch sensitivity factor. So as you're going to provide some discontinuity over the shaft, that's what for mounting purpose, you may going to cut the keys, you may going to drill the holes, or you may going to say make some splines over it. Okay. So as you're going to change the cross section, so it is going to give some stress concentration. So that's what it should give, some low stress concentration. So where it has a coincident with the notch sensitivity Q factor. Fourth one is it should have a good heat treatment properties because the shaft is going to be used in different environments. So that should have a good heat treatment properties. So wear and tear may occur if it is mounted in a bushing. Okay. So next, it may be used in some. One example I can quote for this heat treatment properties like crankshaft. Okay, crankshaft which is going to be used in IC engines. So it has enormous amount of heat is going to produce, so that it is transmitted to the crankshaft through the connecting rod as well as piston. Okay. So next, it should have a high wear resistance, resistant properties. As I said, it's going to be mounted between the bearings as well as journals. Okay, if it is mounted over the bearings, then no problem of wear and tear. If it is mounted in a bearing, there is no problem of wear and tear. But if it is mounted in a journal, so then wearing of the shafts will take place. Wearing of the shaft will take place because of the friction between the journal lubricant as well as this shaft material. Okay, so now these are the requirements of a shaft material. Now let us go for shafts material here. So you're going to get some standard shaft materials. Okay, you're going to get some standard shaft materials. So based on Indian standard designation, so the preferred steel materials for manufacturing of shafts. Okay, so one is 40C8. 40C8 is one. Second one is 45C8. Next 50C4 and 50C12. 50C12. Okay. So now when a strength of the high strength is required, so then an alloy steel such as nickel chromium or chrome vanadium steel may be used. Okay. So now these are the carbon steels. These are the carbon steels with the 0.4 percentage, 0.45 percentage with some alloy factor. Okay, so the normally material used are listed here. That is what a carbon steels of grades 40C8, 45C8, 50C4, and 50C12. Okay. Now, if you come to the what you can say the manufacturing of shafts, so shafts are generally manufactured by hot rolling. Okay, and finished to the size by cold drawing or turning and grinding. Okay. So the rough shafts are going to be produced by hot rolling. Okay, or produced by hot rolling. Next, if you need the required size, okay, and the surface finish. So surface finishing is going to be done with the help of some grinding. Okay, grinding. So that one more thing is you can use the manufacturing. You can go for manufacturing of shafts by using cold drawing procedure also, cold drawing procedure, or you can go for the turning operation, which is going to be used in a lathe to get a planar surface. Okay. Another thing is so the types of shafts are again classified based on the applications, whether they are going to use it for only the transmission of power or whether they are going to be use an integral part of a machine. Okay. So now based on that one, you're going to get two types here. Okay. you're going to get two types. Now this is what the materials. This is what materials. No. So types of shaft based on the application. Okay. So one is what? The transmission shaft. Transmission shafts. So second one is machine shafts. Okay. So transmission shafts are going to be used to transmit the power between the source and the machine. So which is going to receive the power. Okay. So that means driver and driven. So machine shafts are the form of an integral part of the machine itself. Okay. So one example I can say for this machine shaft is a crankshaft here. A crankshaft. So here you can say transmission shaft as a line shaft. Okay. Now, so standard sizes of transmission shafts. So for this one, you can refer design data handbook. That is what in a chapter number 3. You have a table here. There is what table number 3.1a. I think so. So we are going to get a standard size of shaft. Okay. Normally, the sizes are in terms of steps from range of diameters. So let us look out. It is possible to see.